Any good idea what this could be? This is actually a mosquito trap. And you may wonder why Microsoft would build a trap for mosquitoes. Well, actually, we had this project called Project Premonition where we applied drone technology to detect the mosquito gatherings and then install those traps that have artificial intelligence built in so that the traps detect the different species of mosquitoes and they can trap them, and then use genome sequencing to understand how different mosquitoes are spreading, to understand the spread of disease. So, I was fascinated by that project because it just shows the really breadth of technology, including AI, that really transforms humanity, something that Tim was also mentioning. And this gets applied everywhere. This is a kind of couple of researchers in the middle of a desert who are launching a drone. But this drone is a very particular one because it actually uses AI not to only detect hot air streams, but also predict them in real time and optimize the algorithm as it flies to stay airborne without the use of energy. And this gets applied elsewhere, using of computer vision to contouring tumors prior to radiation. Winning Pac-Man, and you may laugh, why would winning Pac-Man mean so much? I think that applying reinforcement learning to Pac-Man allowed researchers to use very similar technique to train models of self-driving cars in virtual environments who can fail and try tens of thousands of billions, millions of times. And this is the type of work that we're doing with some of the car makers as well to help make it happen in the controlled circumstances. So the reason why I mentioned all this is because I really believe that AI gets to transform the society through democratization. Various tools that my predecessor mentioned and I showed, these are the things that are kind of off the shelf. Different companies or individuals can use technology to improve the outcomes of the organizations or the way they work. And AI is not something really new. One thing to remember is that the first time machines were able to count better than humans was a long time ago. The first voice recognition has already happened decades ago. First self-driving car has happened early 90s. 150 kilometers, I think Daimler car has made on the highway. But what has changed completely today is the ability to use and the harness power of huge amounts of data and the power of the cloud, so the huge computing power, and then the algorithms that are extremely powerful and allow to make those things happen. So as a company, we understand that we bear responsibility with the developments that we are actually making. So we have started thinking about ethical framework, and we're not the only ones. European Commission mentioned the ethical aspects already in its strategy in 2018, and this work has been advancing, and many of you have been working on. And as a company, we also developed 6 principles that we are applying to AI development and deployment. And I walk you briefly through them because I believe that they are really important to potentially frame some of the conversations we'll be having now on the panel as well. And the first one is fairness. And if I mean by fairness, I mean to understand how potential bias in AI can be introduced. Allow humans to understand them, and I develop techniques that are able to detect them and potentially mitigate them. And when I mean bias, it's not only whether you get a loan or not, it's more whether you get hit by a car or not, just because your profile is not white person walking on the street. The second aspect is reliability and safety, and evaluation of ongoing performance and monitoring it and allowing to feedback. I give an example of self-driving cars. It's a really important one to think about as well. The third one, privacy and security, and I somewhat think that on privacy side, it's kind of easier because we believe that GDPR does apply to AI. But on the security side, there's a lot of conversations happening around malicious input into AI algorithms. So thinking how you develop AI to make sure that malicious input can be potentially detected and differentiated from the genuine one, those that actually allow to train AI models. And finally, inclusiveness. And by inclusiveness, we mean to ensure that there's no digital divide, so people don't really get left behind just because potentially they are of disability. And an example of that, one of our researchers who's visually impaired, they have been developing with him a set of glasses that allow him to use the cameras and computer vision to provide him with real-time feedback of what he sees in the front of him. Humans, different animals. Is he walking the street? Are they listening to him? Are they sleeping? Are they smiling or not? And currently, this technology has made it to an app developed and actually available for any of you to download. So technology also needs to make sure that people of all abilities can benefit of this wave. The two underpinning principles that are also not to compromise is the principle of transparency of the algorithms. And by transparency, I mean that humans should understand how decisions are being made. Tim mentioned a question of an algorithm detecting whether there's a cat. There was actually a case when the algorithm was supposed to differentiate between cats and foxes, reached a nearly 100% accuracy. The challenge is when it was applied to a different geography, it had very bad accuracy. And only drilling deeper made people realize that the algorithm was not detecting foxes. It was differentiating background of the images, because the dogs were pictured in the house and the foxes were pictured in the forest. So understanding how decision is being made is equally important than making sure it's actually accurate. And final one is accountability. So we believe that humans should be accountable for the algorithms that they develop and deploy, regardless of the circumstances. So just to wrap up, maybe two foods for thought. Kind of looking into the future. In order to, as I mentioned earlier, in order for AI to be successful, we need computing power, but we also need data to be stored somewhere. So what you see here actually is a picture of a quite recent successful project when our researchers who work on the DNA storage managed to automate that process end-to-end with, I think, University of Washington. And why would you be interested in DNA storage? Because you can store in a cube of sugar as much data as you can currently store in a data center. For the future of all the data generated, this is something what we need to think about. And second one, and I'll leave it here, is this is a component of from our quantum computing research lab. And quantum computing will really change everything in the foreseeable future, just because of the computing power that will allow us to make things with AI that are currently impossible to think about. And looking forward to discussing more with my colleagues here on the panel. Thank you.